Hey guys, sorry about that. The stream got interrupted by my software or something. My streaming software got all clogged up. But I am back. I am back. Okay, so we're gonna attempt to... Hey folks. We're going to attempt to build this four-way image morph kind of from scratch, I guess. Maybe not all the way through, but some of the way. Or I may just decide to use the one I already have on screen. I'm trying to decide. Are you going to do any ransomware? I'm not quite sure what you mean by that. Yes, let us actually start from scratch, because that's my newest hobby. I'm going to start with a load checkpoint. Drag your model over into KSampler. And let's get a basic workflow up and running. One second, folks. There we go. All right. You sent me something nice I can use. Oh, nice. I'll take a look. JS Craviero. But okay. So everything that we do in Comfy typically starts with a load checkpoint node, because we need to actually know which model we're going to use for our design. And that's going to help inform whether it's realistic, cartoony, anime, what have you. So we'll stick with the one that's already in absolute reality. It's a pretty good one. We'll change our sampler and scheduler to LCM and then SGM uniform. And let's see now. Let's set our seed to fixed. Actually, let's convert the seed to an input so that we can control it globally. We'll drag that out to a seed everywhere node, which is great for transmitting seed information across to all nodes that need it, just so we can use one uniform seed across all of our workflow instead of having to manually make sure it's the same. Yeah, thank you very much, Reese. I really appreciate that. It's very kind of you. So for our seed everywhere, we will fix it so it doesn't change. We'll just set it to something easy, like 444. We'll set our steps to 12 and our CFG to 2. Actually, maybe 1 we'll do for the CFG. We're going to need some conditioning, so we'll give ourselves a positive and a negative prompt for just that. Plug those into our load checkpoint and plug them out into our KSampler so that it knows what's positive and what's negative. And we'll color code them just for our visual aid. Not required, but it does help. We'll just give it a dummy prompt like a happy orange. We'll give a negative prompt like NSFW nude, because we don't want any of that on our live stream. Want to get flagged today. You have to be stopped. Yeah, well, I just like bringing weird monstrosities into the world. My imagination is kind of an insane place to live. And so empty latent. And for the empty latent, we are going to change everything to input so that we can control all 3 of those globally, because we're going to have some other nodes that will need this information. So it'll just help to have them all available globally. So width, height, and batch size, which is basically frame count. And we'll do a primitive integer. We'll name that width. We'll do width, height, and frame count for all 3 of these. Width, height, and then frame count. Okay? Frame count. Oops. there, plug that in, and then plug that in too. And we're going to want an upscale image node, which we'll be using multiple times. Upscale image. This too will have an input for the width and the height. Convert, crop to center, upscale. We'll set that to Langsos. Thank you, Untune Melodies, I appreciate you. So for this, we're going to want the width and height to communicate with our upscale image node, which will be used later on for various images and videos that we'll just want to size appropriately as it's being inserted into our workflow so that it crops to our desired canvas resolution, which we will set to 320 by 560. We're just going to want every input video and image to cleanly and just crop to these dimensions appropriately. If they were not already 320 by 560, they will be by the end of this workflow. That's kind of the idea. So we'll just kind of have that off to the side on standby. We'll move these over here. We're going to need to decode our results from latent space back into pixel. So we'll plug that into the VAE. Actually, we'll do a separate load VAE node for this one. Probably be better in the end. And then we're going to preview that out right there. Let's just see if this is working right out the gate. Q prompt. Cool, looks like we're working. Except that is not a cat. I mean, it's not an orange. I asked for a happy orange. You know what? I think it read that as orange tabby, so it just gave me like an orange tabby cat or something. An orange fruit. My goodness, what if we just do that? There we go. Now we have it working properly. Yes, indeed. If y'all have any questions about what I'm doing, feel free to ask. I'm happy to answer. But at a very high level, I'm making AI-generated images and videos using open source means. An open source program called Comfy UI. And it's a lot of fun. It's based around nodes, different nodes that connect to one another and do different things and transmit different things to each other to ultimately create results like this. That's generally the idea. But now we want to blow this out into an animation workflow instead of just for images. So we're going to start by inserting our animate diff stack. Animate diff is short for animate diffusion, and it's an extension for stable diffusion that brings animation into the fold. Takes stuff from just static imagery out into, animations. And carries a context window across multiple images to create what appears to be an animation. Very, very fun. So we'll start with the evolved sampling. Or will we, actually? Yes, I think that's fine. So M models will be this. So this is where the actual model will be applied within this node, but it's going to need a few things. For one, it's going to need to know what the actual animate diff model is, and for this we're just going to use animate LCM SD15. That's pretty standard. We'll do a motion lure as well, although this is optional. I'll set it to zoom in. I'll hide it for now though. Bypass it for now. We don't really need it right now. We'll do context options. This is mainly to allow us to make perfectly looping videos. This is what this is for right here, just in a nutshell. And we should more or less be at a place now where that is capable of animating our workflow. So let's continue. Today you also will do something from zero with us. This workflow is kind of from scratch, kind of from a starting point of zero. I mean, obviously there's the installation of Comfy and all the requisite models and everything like that. I won't be running through that today, but I am sort of trying to just walk folks through like the actual arrangement of nodes from start to finish, like which nodes you put into your workflow and what they connect to ultimately get to an animation that you're going to see in a few minutes once this is finally functional. So now that we have animate diff, we're going to need to plug it into a model chain, the model chain. But first we're going to want a LoRa loaded in. for the LCM functionality. Flora model only. This will be LCM 15.19 for the strength. And then that's going to plug right on into our evolved sampling, which will then go back into K-Sampler. So we've just intercepted the model chain with the introduction of this animate diff stack, which will, like I said, expand our capabilities into the realm of animation, as opposed to just static images, which is where the real fun is. Hey everyone, how's it going? Alrighty, so now that that is in place, we're going to want an IP adapter. Let's start with the unified loader for it. An IP adapter at a very high level is a digital set of eyeballs for your AI. It allows you to insert images and prompt your program with images instead of text. So instead of having to write out something like an orange fruit, you can literally just insert an image of an orange, and this digital set of eyeballs will analyze that picture and be able to intelligently create results from it, or modify it, or take whatever elements it needs from that image to play around with your workflow. So it's a very, very powerful extension of Comfy UI. It's a series of models and nodes that need to be installed ahead of time, though I will not be covering that in the scope of this stream. But in a future stream perhaps, and also in my course that I'm working on that should be released in the coming weeks, we'll definitely go into detail about how to install something like this. But for now, it's already installed, so I'm just going to show you how to actually add it to your workflow. It all starts with this node right here. It's called an IP adapter unified loader. We'll set that to plus. And it's also going to need an IP adapter itself, which will take in the image and manipulate it accordingly. And there can be as many IP adapters as you want. Basically, the sky's the limit there. And the idea is the more IP adapters you add, these would all represent different images that you would insert. And as you insert multiple images, the IP adapter will essentially mash together all of those images into one like monstrous result of like just an amalgamation of all the different styles. It's very fun to go crazy. Oh, thank you, Chris Start. I appreciate it. But for today, we're just going to use one image for the IP adapter. I'm not going to go crazy with... No, that's actually wrong, because we're attempting to build out the four-way image morph workflow. So in fact, we will be doing 4 IP adapters here. Let's start with just the one for now, though. Let's just make sure it's actually working. So we're going to need to plug this into the model chain. Let's intercept it right from here. Take the output of your animate diff model chain, plug that on into your IP adapter, unified loader, and then from unified loader, pipe that into your IP adapter, and then finally from IP adapter, plug that right back into K-Sampler, which is the final destination for the model chain. Ralcon Tattoo, this program is called Comfy UI. Comfy UI. And in fact, maybe I'll just write it on screen real quick for y'all. Let's see. Text. Program name Comfy UI. Let's see. Maybe this will help. Maybe that's a bit too big still. There we go. Right, that should help clear some of the frequently asked questions up. But let us return to our workflow now. And we're going to need this node we created earlier, the upscale image node. Paste that on in again. We're kind of just keeping this one up out in the rafters, I think is the term, just kind of on standby, so that I can copy and duplicate it as it's needed. Because what I can do, it's already plugged into the right things that it's going to need. It's receiving the width and height information from our global. It's going to need that. So in order to duplicate this for other uses, we can Control-C it, and then do a Control-Shift-V, we'll paste another in place, already connected up to where it needs to be connected. So that is very useful to us. So we're going to need it here for our IP adapter, and we are going to actually need to load in an image with the load image node. See, that plugs right on into the left. And that's going to be basically optimized for our IP adapter and our workflow so that it matches up with our global resolution in a really clean way, because the input images aren't always going to be the right resolution. So now that that's been upscaled and resized, we will finally then plug that into our IP adapter, and it should be ready to go. Let's find a different image though, just something stylistically interesting, because we're going to adopt its style this time for our test. So we'll paste this cool image in, and we'll change standard for weight type. We'll change that from standard to style transfer. And so now what's going to happen is it's going to adopt the styling element, the style of this image, into whatever we typed for our prompt. So we'll use the same prompt, an orange fruit. We'll literally just run it all over again. But hopefully this time, it'll give us a fruit that's in the style of this weird psychedelic image. And okay, so it's definitely psychedelic, but it's not an orange, so it appears we've taken a misstep somewhere. Next, the color with the fruit. I'm not quite sure what you're saying there. So I would like to maybe set this down to medium strength instead of high. Still not really coming through. So what exactly? Let's start by turning off our animate diff stack, because it's not an animation yet. Okay, we're back to images now. I think the animate diff was throwing things off. What we're trying to achieve real quick, just to make sure the IP adapter is working, is we're trying to see if it will adopt the style of this image and apply that over our actual prompt that we've written, orange fruit. So I'm just gonna like tweak these settings a little bit to see if we can make this happen. Okay, plus now trippy orange fruit maybe. Now it's not really working the way that I wanted it to. What if I change this to standard? Okay, if I change this to standard, it pretty much just pipes it through unchanged. That prompt is more important. How about that? Ah, now we're getting somewhere. Oh, that's really cool, actually. Well, I think the point is that it is working. It is listening to our IP adapter. The focus of this, though, will not be on image generation, as fun as this is. It's ultimately going to be animation-based, so as long as we know that the IP adapter is at least functioning right now, which it appears to be, then we're in a good spot. Unfortunately, it's not doing a style transfer the way I would like it to be doing. Maybe if I type in eyeball, maybe the prompt itself matters here. See, it's not really... Well, I guess it's kind of taken the style of it, I guess. Yeah, let's try a different image. Maybe we'll try this style. Okay, so it's definitely taking some of the stylistic material, because now it's a green eye. I think that's all the evidence that I need that it's working. Ooh, that's pretty cool. I used this picture of lava with the eyeball, and now we're getting a lava eye. It's very cool. The chef is cooking now. You got that right. Go green, it works. Yeah, the green one was really solid, wasn't it? This is pretty sick. That's really cool looking. I'll save that, actually. Alright, well, we have all the evidence we need that IP adapter's working. Let's turn animate diff back on. And let's actually see it make a short animation for us. We'll set it to like 60 frames, which is kind of on the high end, but it won't take that long. Let's queue up the prompt again. Let's see what we get. know what? We're also going to activate our motion LoRa. So let's type zoom in to the prompt, because for this motion LoRa, it prefers to have a trigger phrase, which in this case is zoom in. That helps tell the program that you want to activate the motion LoRa and use its properties. So 70%. Are you saying 70% for the motion LoRa or for the IP adapter? It might be worth setting the motion LoRa down to 70. 100% is typically a little high. Ooh, very pretty. But we're actually going to need a video combine node now that we're into the realm of animation. So video combine, we will set this to an H.264, CRF to 12. Everything else, frame rate is also 12. Okay, so now we actually see it animated. Beautiful, beautiful. Very, very cool. It's fun to bring images to life. Let's set the resolution to 512 by 512 because it's better to use a 1-to-1 ratio for the stream, since it'll fit better into the actual OBS window for y'all. And after that completes, we're going to advance on to the next section, which is control net. And then finally adding more IP adapters so that we can morph between 4 different images. Insane, wow, yeah, it's pretty crazy, huh guys? That's doing its thing. And here we go. Kind of looks like a chameleon eye or something. Pretty dope, pretty dope. All right, let's try to organize a bit here real quick. So all these right here, this is our, I guess our settings you could say. Let's put that in a folder. All the folder settings. We'll put animate diff all in its own group as well. Did I say folder? I meant group. We'll call this group animate diff. Like so. See, animate diff. All right. And our IP adapter can also go in its own folder, although we're about to expand it because we're going to have 4 IP adapters. So we'll just keep that down here actually, and we're going to grow it out to support a total of 4. Reptilian, yes, it does have some reptilian qualities to it. All right, so let's duplicate the IP adapter X3. So that's 2, 3, 4, grand total of 4. And basically the only real way to connect these up is to make sure they're all getting threaded through with the model chain. So as you might recall, the model chain first piped into unified loader, then into our first IP adapter, and then it has to go into the second IP, then the third IP, and then finally the fourth IP. And this fourth IP adapter is the one that's finally going to pipe back into our casing, like so. So now we're set up for the 4 different images we're going to want to use to morph between, but before we can even start to do that, we're going to need, we're actually going to need a different kind of IP adapter. We're going to need the batch advanced. In fact, it might not even have to be batch. It just has to be the IP adapter advanced, because we're going to need to plug in an attention mask. Oh, you know what? This already supports attention mask. We might not need these extra nodes after all. Let us try and get by without these, I think. I think this might be a little too much. We won't need all these settings. Let's try and get by without it for now. But we will need attention masks in each of these, so let's drag that out and search for, it's going to be a fade mask. Create fade mask advanced. Create fade mask advanced. Beautiful. And let's minimize the upscale image nodes to save some room. Let's move these down a bit. And let's start plugging this in. So that's going to be number 1, number 2, number 3, number 4. Plug those in accordingly to the attention mask. That was such a journey from an orange, yes. Yes, I know. It sure was. All right, now we need to make sure these values are actually correct. At the moment, they are not. More or less, these values do denote, it's kind of like where the images fade in and fade out along the timeline across all of your set amount of frames. In this case, it's going to be like 96 frames that we're going to use. But these numbers here, the ones in the 1.0, 0.0, these basically denote where in the timeline the images will fade in and fade out. As one fades out, the other starts to fade in, etc., etc. So that's the idea, generally speaking. And luckily, I have... Oh no, where'd it go? Smoothest transition. Bear with me 1 second, folks. I gotta find the actual values for this. Buried in one of my old folders. I gotta invest in a faster external hard drive. I have a 5 terabyte hard drive, but it's so like archaic in how it reads and writes to the drive. I should have known when I was getting a good deal at Target that it would not be the most performant hard drive out there. But I just couldn't. For 5 terabytes, the price was like $100-something. It was unbeatable. So I had to do it. But I'm going to want a much faster hard drive one day. Smoothest transition blend. I think that's it. Smoothest. There you are. So let's just really quickly get these locked and loaded. Almost. Okay. Well, okay. At least we have the one we're looking for. Perfect. So these are the values that we will use for all 4 of these IP adapters. 1, 2, 3, and 4. And these are pretty arbitrary. Like, they can be kind of whatever you want. It's just a matter of preference. If I may, what is your favorite color? Blue is probably my favorite color. Always really has been. Okay, now that the fade mask is in place, let's, oh, we're gonna need, though, to change its frames to an input, because we're gonna want to tell it the amount of frames in a global way. So convert widget to input. They're each going to be frames. And that's going to be received by our frame count node. See, like so. That's number 1, number 2, number 3, and then number 4. Beautiful. Okay. Now our IP adapter is basically done. We're just going to need to fill it with the images that we want to morph between. But the logic for this actual workflow is not complete yet. So we still have a little ways to go, but we're almost there. Stay with me. Is the music a Spotify playlist? No, I actually made these songs myself using Suno AI, suno.com. It's a really good website for just generating some AI music that isn't at risk of copyright strike, which is a big thing right now, streaming. But now that I made all this music, I guess myself, with the assistance of AI. But let's take a look. We'll name this group IP Adapter. IP Adapters. And I think lastly here, we're going to need our actual control net. But more or less, we're kind of already there. We just need a few more extra steps. Let's actually organize this as well. Let's move the seed everywhere down into settings. And this will be our output or our diffusion cluster of nodes right here. Yeah, so let's put those in a group, call the group diffusion, because this is where the diffusion takes place. And we'll move that up to the right, kind of out of the way, so we can make room for our control nets. What software is this, Gina? The name of the software is called Comfy UI. You can actually see it at the top of your screen right now, I think. So let's do advanced control net, apply advanced control net. And again, we're going to need an upscale image node for this. Let's bring that on over here. And we're going to want to load video background path. Let's find a good video for this. I have just the one. It's gonna be this one right on here. This one right here will serve as our control net transitional animation. Yeah, one sec, guys. All right. Okay, so we plug the load video into our upscale, and then that into our actual control net. We're going to need to also denote which model used for the control net. We'll use QR monster. We'll set the strength to about 4. The end percent will be 3/4. And we're almost done with our control net here. Although what we do need to do is, and luckily I screenshotted this earlier, this is the one part I'm still trying to memorize, but I will eventually. Where is it? Screenshots. Okay, here we go. So, simple math repeat. Repeat image. Repeat image batch. Okay. And split image batch. We have repeat image batch, split image batch, and also a simple math. Simple math. What we're going to do here, in essence, without getting too into the weeds, we're taking our input video, which may not already match up with our total frame count from the outset. This set of logic and these 3 nodes will allow us to, I guess you could say, extrapolate the amount of frames in our input video, spread it across the actual total frame count of our video, so that it kind of matches up perfectly in that way. Oh yeah, Gina, it's called Comfy UI. You can find it if you just Google it. If you just Google Comfy UI download, Comfy UI download. One of the first links should be its GitHub page. For me it is. Just find its GitHub, and once you're on the Comfy UI GitHub, head over to Releases on the right. There's a Releases tab, and under Releases, the latest release version should be at the top here. Look inside of the Assets expandable menu here, and then just download this file right here, Comfy UI Windows Portable NVIDIA.7z. Yeah. Gotta wrap up in a few minutes here, folks, but let's just see if we can at least get this functionally up and running, this 4-way morph, because I do want to see the results, as I'm sure you do as well. So let's start by taking this. So first we're going to need, the first node is a simple math equation. We're going to divide the total frames of our workflow, divide that by the total amount of frames in our input video. So it's going to be A divided by B. And we're going to set the total frames to 96. And we're going to force the rate to 12, so it's a 12 FPS video, since that's the rate that I'm targeting in the project. Oh, thank you, Brandon. Much appreciated. Yes, I probably should advertise these quite a bit more. I'll start thinking about that. So now that we have done that simple math equation, we're going to bring that into... let me try and recall. So we're repeating the image batch. Yes, we're repeating this image batch. And that will be going in here. Yes, I see now. The split index will be this right here. No. Oh, right. Okay, so amount. The amount is the math that we just performed, and we're basically repeating this video's batch of images. We're multiplying that by the math that we just performed here, the A divided by B. And now that we've done that, we can finally plug that into our split image batch, which is at a split index of our frame count here, 96 frames. And now, finally, we can take the result of that and plug it into our control net. And that should be everything we need it to be, if I'm not mistaken. And I hope I'm not, because I really want to see this work. So actually, we might be in a place where it functions now as it should. Let's go and plug a few really creepy images into the morph. ones that I really like to use from time to time. Just some Halloween themed skulls and rotten figures. And let's give it a rip. Let's cue prompt cautiously because I don't know if everything is connected. I think though that it is. And if all goes well, we will get a pretty nice looking 4-way animation, 4-way morph. So far, so good from what I can see in the preview. Model are we using? I'm going to want to change that model up to a different one that I like. But first, let's see what this looks like. Oh, I just realized, guys, it's actually not going to yield any. It's going to look like this again, essentially. And the reason for that, let's see what it looks like first. Yeah, so it's just another version of the eye, but different color. The reason is because we haven't actually plugged our control net back into K-Sampler. This is an important step. So from our positive and negative prompts, because control nets live on the conditioning chain of Comfy, and the IP adapter lives on the modeling chain of Comfy. So that's an important distinction. So let's plug the positive into our control net, as well as the negative. And then from the output of our control net, that will go right back on into K-Sampler. All right. Now it should work. Now let's see what happens. Oh, thank you so much, Sheena. I appreciate you. I do my best. I guess you could say it's an obsession, you know? I think everything else is looking good. Oh, we didn't set these. We need to set these from style transfer back to standard because we're not trying to transfer a style anymore. We're actually just straight up using these images as our inputs. And so let's just do that actually. Let me actually cancel that out. Let's run it one more time. Just trying to make sure everything works as it should. Let's change the model to the one that I like, Realism by Stable Yogi. And maybe now we're in a good spot for it. Let's see what it yields this time. Let's see what we get. Let's see what we get. In about 40 seconds from now, we will see if it's actually working. It would be amazing if it was. Which batch? Split image batch. Yes. Okay. Yeah, that makes sense. Alright, let's see what we get. Let's see what we get. Yay! It's working! And there you have it, folks. A finally functional 4-way image morph workflow. Really, really cool to look at. And just as a bonus, before we sign off, let's interpolate the results so that it looks even cooler. Interpolation means to increase the frame rate of a video. So because it's currently 12 frames a second, we're going to bring that up to 60. And the act of interpolation is basically creating or inventing new frames in between the frames to bring something up to a much higher frame rate. So that is what this looks like right here. And I think, well, I think with that, this is a pretty good place to park it. Can you share or can I buy the workflow? I'm not really sharing out the workflow at the moment, but that is likely to change pretty soon as I figure out kind of which angle to approach this with. For one thing, I am putting a course together right now, and the course will, among other things, it will walk students through how to create a workflow just like this. And I'll be sharing more details about that in the coming days and weeks as it approaches release. But I may even also include some workflows with that course. Like, if you subscribe to the course wherever I upload it, you'll probably have access to workflows as well. So yeah. Good stuff, you guys. I think this is a nice place to park it. I have to sign off for the evening, but yeah, thank you so much for your viewership and just showing interest. Really appreciate y'all. All right, have a great night, guys. I love you very much. Take care.